In this video, we're going to talk about endothermic and exothermic reactions, so let's go ahead and get started. Some key definitions that you want to keep in mind. A system is a part of the universe being studied. The surroundings is the rest of the universe that interacts with the system. The reactants are always the start of a chemical reaction, and the products are anything that it produces in a chemical reaction. A chemical reaction is a process in which one or more substances are converted to one or more different substances. So remember, it goes reactants into products. We're going to see some of these key words here today. So an endothermic reaction, we have our system and the surrounding. So heat is going to go into the system from the surrounding. An exothermic reaction is going to release heat. It's going to be very hot and it's going to release heat into the surrounding. So an exothermic reaction is going to feel hot to touch, and an endothermic reaction is going to feel cold to touch. So endo has a D in it, and cold has a D, which is the easiest way to remember that. Exothermic is very hot, and exo sounds like exit. You exit the building when there's a fire or heat. So here are some key things to know about endothermic and exothermic reactions. Endothermic reactions, you have your energy plus your reactants, and it's going to produce a product. So an endothermic reaction, your heat is absorbed. It's going to take it in. It's going to absorb the heat from the surrounding area, and the energy of the product is going to be greater than the reactants. The examples are sweating, evaporation, baking bread, or melting ice. In an exothermic reaction, heat is going to be released, and the energy of the products is less than the reactants. So we could see in the equation, its reactants is going to yield products plus energy. So some examples would be combustion, water and calcium chloride, and lighting a candle. So which one of these is going to feel hot to touch? If you said exothermic, you're right. Which one of these is going to feel cold to touch? If you said endothermic, you're right. Which one is going to produce more energy upon completing the reaction? If you said endothermic, you're right. Which one is going to produce less energy upon completing a reaction? If you said exothermic, you're right. So what does this look like on a graph? This is an example of an endothermic graph because the heat is being absorbed. There are more products than reactants, and the total amount of energy is here. So since we are absorbing heat and the products are more than the reactants, we know it has to be endothermic. Oppositely, we have exothermic, and the heat is being released through the products. Since the products are less than the reactants, we know that the heat was released throughout the experiment. Here are a few examples of endothermic and exothermic videos. I highly recommend you go ahead and Google them. There are some great examples out there. So in an energy of a system, there are many phase changes that take place. As the energy increases, you have an endothermic reaction, and if the energy is decreasing, you have an exothermic reaction. So here we could see the energy going up, and as the energy increases, so does the disorder of the system. So the particles become more disorganized with the more energy that you add. So let's go through these. When we go from a liquid to a solid, we could see this arrow right here. What type of reaction is taking place? If you said freezing, you're right. Think about water. When it gets very cold outside, it freezes into an ice cube. What's the opposite of freezing? Going from a solid to a liquid? We know that that is called melting. Our next phase change is going from a liquid to a gas. So think about water again. If you put water on your stove to boil, it goes from a liquid, you could see the steam coming off, turning to a gas, and that is called vaporization or evaporation. Opposite vaporization is going from a gas to a liquid, and this is called condensation. Sometimes you see condensation on your bathroom mirrors if your shower is hot enough or if you're in a car and the windows get steamed up. The next one we're going to talk about is going from a solid to a gas. Does anyone know what this is called? If you said sublimation, you are correct. So sublimation takes place, you see it a lot around Halloween time. That's when dry ice, you have a block of dry ice, and it gives off gas. You see all that like gas that makes Halloween decorations look all cool and creepy when you turn out the lights. The last phase change we're going to talk about is going from a gas to a solid, and that is called deposition. You see this oftentimes high in the mountains when the cold air freezes almost instantaneously and it deposits. Okay? Hopefully you learned a little more about endothermic and exothermic reactions today. If you have any questions, please let me know.